Hi, and welcome to the mean value theorem for integrals. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. Chapter 4, Integration, is a calculus lecture. It comes to us from Larson's 11th edition calculus text, 4.4, the fundamental theorem of calculus. And this is part 2 of that section. I'm specifically going to talk about the mean value theorem for integrals and average value. So what are these? Let's make this so you can read the whole screen. Hopefully that's better. The mean value theorem for integrals states, if f is continuous on the closed interval from a to b, then there exists a number c in the closed interval such that the antiderivative from a to b of f of x dx is equal to f of c times b minus a. What the heck does that mean? First of all, I'm going to move this up. Give me some room to write. What that says is, for any function, I don't know, here's some function, and I want to find the area from A to B. So we're looking for this area, and what this guarantees is I can somehow normalize it. Maybe I can find this value C so that the area under the curve is equal to a height of f of c times the width of b minus a. It's almost rectangularizing what's going on. So my regular function f of x has an area, and we could find that area. We did that in part 1. But the mean and average values tell us there's some c in between a and b. As long as f is continuous, there's got to be a c in there so that the height at c, f of c, multiplied by the width of the interval is exactly equal to the area. And as it turns out, this f of c is the average value. So the average height over all this interval is our f of c. So the average value on an interval comes directly from our mean value theorem for integrals. Let's do some work on this. So we're going to find the value or values of c guaranteed by the mean value theorem for integrals for the function over the given interval. Here's f of x equals x cubed. Our interval is from 0 to 3. So our setup. I know the f of c is c cubed. All right? B minus a, that's the length of the interval. 3 minus 0 is 3. So what the mean value theorem for integrals tells me is the area from 0 to 3 of x cubed dx is f of c, c cubed, times b minus a, times 3. So let's work on this left-hand side, this antiderivative. We know the antiderivative of x cubed is x to the fourth over 4, evaluated from 0 to 3. 3 to the fourth over 4 minus 0 to the fourth over 4, I just call that 0. If 3 to the fourth over 4 minus 0 is equal to our f of c times b minus a, that means 81 fourths is equal to 3c cubed. So 81 fourths equals 3c cubed. I can divide both sides by 3. C cubed equals 27 fourths. To get c by itself, I'm going to take the cube root of the fraction. The cube root of 27 is 3. The cube root of 4, I don't know. So we call it the cube root of 4. But if I multiply both numerator and denominator by the cube root of 2, because 2 times 4 makes 8, I have a perfect cube under the radical, and I get a 2. And I multiplied the numerator also. 3 cube root of 2 over 2 is the value of c, guaranteed by the mean value theorem for integrals. Alright, so I know where to find it. And f of c, substitute that value into our function, cube that, and we have our average value. Number 2. Our function is x minus 2 square root of x over the interval from 0 to 2. So we know the f of c is c minus 2 square root of c, and we know the length of the interval b minus a is 2. So let's, instead of setting up that equation, let's just look at the left-hand side. The integral from 0 to 2 of x minus 2 square root of x is the same as the integral from 0 to 2 of x minus 2x to the 1/2 dx. I think I forgot the dx. I didn't forget to type it, I forgot to say it. Dx, very important. The antiderivative of x is x squared over 2 minus 2. The antiderivative of x to the 1/2 is x to the 3/2 over 3/2. Evaluated from 0 to 2, just a little quick note here. Instead of dividing by 3/2, when we multiply by 2/3, 2 times 2/3 will give us the 4/3. When I input 2, 2 squared is 4. 4 over 2 is 2. Minus the 4/3. X to the 3/2. 2 to the 3/2. 2 to the 3rd is 8. The half is the square root. Substituting 0, I get zeros. I love zeros. That is, let me see, the square root of 8 is the square root of 4 times 2. That's 2 times square root of 2. 2 times 4/3 is 8/3. Now, that's the easy part, believe it or not. Calculus is always the easy part. It's the algebra that kills us. 2 minus 8/3 square root of 2 is equal to f of c times b minus a. Right? The antiderivative is equal to f of c times b minus a. Here we go. Let's throw down some algebra. Let's divide both sides by 2. When I divide the right-hand side by 2, I just get c minus 2 square root of c. When I divide the left side by 2, 2 divided by 2 is 1. 8/3 cut in half is 4/3 square root of 2. Setting this equation equal to 0, c minus 2 square root of c minus 1 plus 4/3 square root of 2. And noticing that it's quadratic in form. Quadratic in form meaning I have a constant term. Whatever my quote linear term is, the other term is that squared. So I could use the quadratic formula in order to find the square root of c and then square that to get c. And you should check these answers because we're supposed to be in an interval from 0 to 2. Check to see which ones of these are in that interval. Is there an answer or not? I leave that as an exercise for you. Finding the value of c, guaranteed by the mean value theorem for integrals, when f of x equals cosine of x, over the interval from negative pi over 3 to pi over 3. Do not just see, hey, look, that interval's nice, let's just call it 0. That's not the way it works. Special things have to happen with the function before the antiderivative is 0, so don't get in that habit. You have to know that it's an odd function before we can do that. So f of c is cosine of c, and the length of b minus a is 2 pi over 3, right? It's pi over 3 to get to 0, and another pi over 3 past that, so 2 pi over 3. My antiderivative from negative pi over 3 to pi over 3 of cosine of x dx is sine of x, evaluated from negative pi over 3 to pi over 3, which is a sine of pi over 3 minus a sine of negative pi over 3. Sine of pi over 3 is square root of 3 over 2, because I have my unit circle memorized. And I know that sine is an odd function, so the sine of negative pi over 3 is negative the sine of positive pi over 3. So I know it's negative square root of 3 over 2, but since I'm subtracting a negative, when I add these two together, square root of 3 over 2 plus square root of 3 over 2, that gets me an answer of square root of 3, the area under the curve of cosine of x between negative pi over 3 and pi over 3. But we want to find the value of c. We're not just finding the value of an integral. We know that the square root of 3 is equal to the length of the interval times f of c. So square root of 3 equals 2 pi over 3 cosine of c. Multiply by 3, divide by 2 pi. Cosine of c equals 3 square root of 3 over 2 pi, so I'm going to take the inverse cosine. Because I'm looking for real numbers here, I make sure my calculator is in radian mode. Always radian mode for calculus. Our value c is the inverse cosine of 3 square root of 3 over 2 pi. And if you're putting this in a calculator, make sure you put parentheses around your denominator. Otherwise, it doesn't know. Your calculator is really not very smart. It's only as smart as we let it be. So make sure you put parentheses around a denominator. And you should get 0.597 radians. 0.597 radians is our c value. All right. So now we're going to find the average value of the function over the given interval and find all values of c for which the function equals its average value. Okay, that's a mouthful. F of x equals 9 minus x squared over negative 3 to 3. We know the average value is f of c, which is 1 over b minus a times the integral from a to b of f of x dx in general. Which means, in this case, f of c is 1 over 3 minus a negative 3. the integral from negative 3 to 3 of 9 minus x squared dx. Well, 3 minus a negative 3, that's a 6. The antiderivative of 9 is 9x. The antiderivative of x squared is x cubed over 3. Don't forget the subtraction in between. We're going to evaluate from negative 3 to 3. So I substitute 3. 9 times 3 minus a 3 cubed over 3, and the 1/6 out in front. Minus 1/6 out in front again. 9 times negative 3 plus 27 thirds. Negative 3 cubed is a negative 27, so if I subtract a negative 27, it's positive 27 thirds. But 9 times 3 is 27. 27 divided by 3 is 9. Negative 27 and a positive 9. What do I have here? 27 minus 9 is 18. Negative 27 plus 9 is negative 18. 1/6 of 18 is 3. 1/6 of 18 is again 3, but these two negatives tell me to add. So 3 and 3 make 6. It turns out that our average value, f of c, is 9 minus c squared, which equals 6. So a height of 6 is our average value. Alright, so I found the average value. And we got to find all values of c for which the function, so find c so that this equation is true. We can do that. If 9 minus c squared equals 6, I can subtract 9 from both sides. Multiply or divide both sides by a negative 1. If c squared equals 3, then c equals plus or minus 3. Our original interval was from negative 3 to 3, so both values of c are in the interval. Oh my goodness, did I really write that? No, red. Red. Because I forgot the square root. See, I caught it before you could comment on that. That's why you always let me finish the slide before you start typing. My bad. Square root of 3 and the negative square root of 3 are both in the interval, so it's all good. Very important to have the correct answers. I need to slow down when I'm typing, don't I? Number 2. If f of x equals x cubed, on the interval from 0 to 1, my average value is 1 over 1 minus 0. Integral from 0 to 1 of x cubed dx. Well, 1 over 1, that's just a 1. I wrote it there so it didn't look like I forgot it. The antiderivative of x cubed is x to the 4th over 4. We're evaluating from 0 to 1. When I put in a 1, I'll have 1/4. When I put in a 0, I'll have 0. So this average value is 1/4, which means for this function, f of x equals x cubed, over the interval from 0 to 1, it has an average height of 1/4. So the average y value is 1/4. But what c value gets us there? I know that c cubed, right, f of c, c cubed, has to equal 1/4. Take the cube root of both sides. The cube root of 1 is 1. The cube root of 4 is cube root of 4. But if I were to rationalize this, I'd multiply both a numerator and denominator by the cube root of 2, because the cube root of 2 times the cube root of 4 is the cube root of 8. The cube root of 8 is 2. In my numerator, 1 times the cube root of 2 is the cube root of 2. So here's my c value, my average value, and the c value that gets me there. Alright, number 3. F of x equals 4x cubed minus 3x squared on the interval from negative 1 to 2. My average value, f of c, is 1 over 2 minus a negative 1. Integral from negative 1 to 2 of 4x cubed minus 3x squared dx. This is a 1/3. The integral, the antiderivative of 4x cubed is x to the 4th. The antiderivative of 3x squared is x cubed. Think about the derivatives, and that makes that an easier one. Evaluated from negative 1 to 2, so I put in 2. 2 to the 4th is 16. 2 to the 3rd is 8, and I have a 1/3 out in front. Minus the 1/3. Negative 1 to the 4th is negative 1. Minus negative 1 to the 3rd is negative 1. 16 minus 8 is 8, so that's 8/3. 1 minus a negative 1 is 2, so I have minus 2/3. 8/3 minus 2/3 is 6/3, which we all know as the value 2. Solving for c, and you might find that odd since I don't have a c in here anywhere, but this should be f of c. Sometimes I just use x, sometimes I put in the c value there, but I'm really solving what values make this function equal to this average height of 2. But when I have 4x cubed minus 3x squared minus 2 equals 0, I'm looking at all my pre-calculus skills and I'm thinking to myself, I could graph it. And I call this one a punt because that's algebra. This is a calculus video. If you could get to here, you could find a way to solve that. I'm telling you the value is 1.137. Use some Descartes' rule of sines or leading coefficients, the rational zeros test. You could get pretty close to this. And if not, graphing calculators are awesome. Finally, number 4, if f of x equals sine of x on the interval from 0 to pi, my average value is 1 over pi, right, that's the length of the interval. The integral from 0 to pi of sine of x dx, that's 1 over pi times minus cosine of x. Right, the antiderivative of sine x is minus cosine of x. Evaluated from 0 to pi, so I'll substitute pi and I'll substitute 0. Keep in mind that cosine of pi is negative 1, so a negative times a negative 1 is positive 1. Cosine of 0 is positive 1, but there's a negative out in front, so that makes it a negative 1. A negative 1 times 1 over pi, and I'm subtracting, so the two negatives make a positive. 1 over pi plus 1 over pi is 2 over pi. I want to know, where does f of c equal 2 over pi? What's the c value? So sine of c equals 2 over pi will give me c equals the inverse sine of 2 over pi. Make sure you're in radian mode. 0.690 radians would be our value of c. 0.69 is in our interval, so we know it's a good answer. The mean value theorem for integrals comes to us in the same section as the first fundamental theorem of calculus. Thanks for listening.